Alright everyone, welcome to building a turn-based game prototype the ECS way. Before I go into the talk, I would like to give you a short setting the stage so that you know what to expect from the next 45 minutes so that you get the most out of this. So mostly because of the time frame, we are not going to build the next civilization game here, so it's going to be very prototypic. It's going to be quite code-focused. So I'm a programmer, so most of the concepts that we're going to talk about are going to be explained in code. And you do not necessarily need a lot of ECS experience already. So I'm going to introduce the concept that we're going to use in this talk. I'm going to try to ease you all in. So as long as you're able to kind of understand code in a little extent, you should be fine. So what we're going to do in the next 45 minutes, I'm going to give you a short slide about my background. Then, as I said, we're going to brush over the concepts that we're going to use in this talk. Then we're actually going to create something. We're going to build a short prototype that will be non-turn-based in the beginning. And we're going to do this using ECS. And then we're going to turn it turn-based, basically. So if this sounds interesting to you, I'm extremely happy to be your host for the next 45 minutes. Something about me, I've been using Unity for roughly a decade now, so for quite a while. During the day, I'm working at Volkswagen in a department that use Unity to actually build tools for the engineers who develop cars. So we develop tools for the developers of cars to make them make better cars, basically. I'm also part of a very small game studio called 3 Games, where we kind of slow cook games in Unity in our kind of free time. So it takes a while, but it's continuous progress, which is nice. And the little free time that is left kind of goes into having a dog and caring about a garden. So if any of those things sounds interesting to you or you have any ambitions on there, feel free to just grab me after the talk. I absolutely love to chat about all of these things. So, turn-based games, they exist in quite a few genres. The more traditional ones are roguelikes, for example. The more mainstream ones, I would say, are games like Civilization, so turn-based strategy games. We have the whole branch of card games like Hearthstone, Slay the Spire, that also are usually turn-based. And then we have the topic of tactical RPGs, tactical shooters that at least offer you a way to play them turn-based in general. And then if you leave the digital world, if you think of board games, most of the board games that are out there are also turn-based. So if we think about a more classical game loop in the beginning, what we have in there is that we continuously run our game systems. So we have different parts of our game that change the game state, and we continuously pull in events from those things, and we update the game state accordingly, which means if you play an RPG, you go to get a coffee, you might, or your character might be dead when you come back because the game kind of kept going while you were away. When we now turn to turn-based game loops, we have a very crucial difference in here. In turn-based games, a frame does not necessarily equate with a turn. So we got this separation, we got two kind of gameplay systems. The first one that also still run continuously every frame, which would be something like input or animation, or if you, for example, have a weather system in your game, you quite likely also want the rain to continuously fall down and not just move a millimeter whenever the player turns, because that would look kind of weird. But we also have the second kind of gameplay system that are turn-based, for example, enemies making a move or the game world changing itself. And for those systems, we have a difference between what is a frame in our update loop and what is a turn in our gameplay logic. So looking at this, we still have this tiny loop or this fast loop that is pulling all the engine systems, if you want so. But we do have this gameplay systems that, we have this gameplay systems that are only updated when certain conditions are met. And this is what we're gonna look at in the next few minutes. And we're going to do this using ECS. I'm just going to give a very brief intro to ECS, so I hope you have heard it at least. It's called Entity Component System. Unity does a few things with this at the moment. So basically, we have entities, which are kind of the new version of game objects. They're just something in our game world, in our game scene. And if you think of mono behaviors, we take all the data from there and put it into components. So a component itself just is like a container for data, and we kind of build up our entities by aggregating different components on this. And then what we have as a third thing are systems, which kind of take certain combinations of components and they transform them. So what this means is we are moving from a more traditional inheritance-based approach, which means we have our class has some data, it has some logic, and then we inherit from this class and it grows bigger and bigger and bigger. Instead of doing this, we're using a composition-based approach. So what this means is we have very little atomic parts, like our components, and then we compose those together to form more complex behavior. This gives us some immediate benefits. For example, systems do not longer really know what kind of things they're operating on. So you no longer say you have a car and the car should drive, and you have an airplane and the airplane should fly. Instead, you might have a component that gives movement behavior, and you have a system that can operate on all those moving behaviors. So you kind of filter our entities based on the components that they are made of. And this is interesting for me personally because it emphasizes something called systematic design that I'm not going to go too deep into, but which basically means that instead of having your logic of the game all written out and designed by yourself, you have a lot of loose systems that interact with each other and that can create kind of emerging gameplay scenarios. So to give you one example, Zelda Breath of the Wild, the Switch game, is a very good example for this because they have the weather system, they have the lightning, the fire system, the weapon system, and all these things kind of interact with each other to allow the player to find creative solutions to gameplay scenarios. So if you're interested in this, there are a lot of talks in the internet. Really recommend checking it out. Super interesting stuff. So why are we doing this with ECS? Well, compared to, for example, last year's Unite in Berlin, it is actually quite usable right now. It's fun to use. It works most of the time. It gives us a high degree of control over our game world. So if you think that most of the systems basically can be stateless, so this means whatever happens in your world really just depends on the components that are in your game world, which in turn mean if you just save out all those components, you get a perfect save game system. And whoever ever wrote a save game system themselves in Unity might appreciate those things. On the second side, we get a lot of performance and data benefits because having those components really isolate the data allows to do some back-end performance increases. So burst compiler and job system are all things that give us a huge performance boost because they can make a lot of assumptions about what the data of the game is going to be look like on an assembly level, basically. So this is also good. Performance is also good in games, and it's going to allow us to use more of those cool systems that Unity is using. It's the last point. Unity is building on top of those stacks, so even more packages will come out in the next year. So for us, it's interesting to start using ECS right now to be able to kind of integrate those new solutions into our game. That's for the introduction. I hope you kind of feel what we are going for, and now we're going to start building our prototype. Just a kind of brief slide. We're going to use Unity 2019.2. something. It's a 3D template. I installed the entities and hybrid renderer package. I also have different content assets from the asset store to make it look a bit more shiny. And there's a GitHub repository that is empty right now. But maybe in a week or something, I'm going to upload the code and the slides so you don't need to write down code or anything. Just kind of enjoy the moment and follow along. So the prototype that we will be building is called Flying Gardner. It is a grid-based world, so we're going to have a 2D grid where the entities will move on. We have two kind of actors. We have the player, which is going to be this nice blue gardening balloon doing gardening things. And we're going to have non-player characters, which are the evil snails that are going to undo gardening things, basically. And the one thing that we're going to look at is 2 degrees of freedom movement. So our actors should be able to move up and down and left and right in our game world. So maybe when we have a lot of time, we can look at some more gameplay systems, but I guess this is going to be the thing that we implement over the next 35 minutes. So how do we get started? We want to have our actors in the game world, which means we want to give them a current position and we want to give them a target position where they try to move to. The ECS way of doing this is to create a component. So when we create a component, we just inherit from iComponent data, which is an interface that is kind of the base for all components in Unity ECS. And in here, we defined two vector3. So the float3 is the new vector3 from unit to mathematics, which denotes our current position and the target position. Now, when you talk about ECS, you have two different kind of approaches. So you can go for pure ECS, which means you do everything in code and instantiate your entities in code and do not have any game objects, mono behaviors at all. Or there's a hybrid approach, which is, as far as I got from the keynote, the approach that will be used in the future, where you author your scene in the editor with normal game objects, and then you convert those game objects on game start to entities. So this is exactly what we're going to do. We have the blue part, which is part of a mono behavior, and we implement this convert function, which means that we take this game object, we do our logic, and we create the ECS part out of this. If you've seen the keynote, a lot of this code is going to be unnecessary in the future, but I didn't change the talk because I didn't know beforehand, so going to brush over this really quickly. One interesting thing that we are doing here, we're actually taking the transform position. So we're taking something from the mono behavior world, and we're kind of transforming it into something that we want to have in our ECS world. So what we do here is we take the position, we round it down to a full number because we are only interested in the grid cell that we are in currently. And then in the yellow box, we create a new actor component and add it to our entity. We're going to not look at this in the editor because, as I said, most of this is going to be irrelevant very soon, so I'm going to skip this. When we have our actors now, what we want to do is we want to move them around. So to do this, we have the current and the target position, and we basically want to interpolate between those two. And in ECS speech, this means we have the translation and the rotation, which are the ECS components that kind of form what was formerly a transform, and we want to change it. And to do this, we want to do it on all entities that have a translation, rotation, and actor component, because those are the three components that we actually need to perform this logic. And the way we do it right now is by using a job system. So this is how it would look right now if you build a job system. We again implement an interface, and we pass in what kind of components we are looking for. And this, like, I grayed out the logic part. We're basically just lerping between the positions. What's interesting here is that we are writing logic for a single entity. So we don't really care about parallel stuff. We don't really care about race condition, because these are all things that ECS backend kind of gonna take care for us. So we just define what kind of components we need. We kind of shape our query for the components. And then we have a function, the execute function, that we implement that will give us the reference to all these components for each entity. And then to fire off this job, we have something called a system. It inherits from job system. And what we do down there is we create an instance of our job. We put in external data. So in this kind, we use delta time to animate, like it's quite useful. And because this is constant for all entities, we put it in from the outside, and then just we schedule the job, and ECS will take care of the rest for us. This, again, is kind of invalid because the way how to write job systems also changed during the keynote. Luckily, it was the only job system that I did for this talk, and what we do now is going to be more relevant for the future. Because now we can animate actors moving around, but what we are still missing to have like the first version of a prototype is kind of the intention to move somewhere. So what we are doing is we're going to create another component called move intention that just contains an int vector of size 2, which just gives us the x and z direction which the actor should move. And now we want to have a system that generates those randomly for our non-player actors. And what we implement here is a component system which has an onUpdate function, which is similar to the update of a mono behavior. And what we do in there is we have a query which goes to all entities, selects all entities that has an actor component, and then for each of those entities, we kind of generate a random direction we generate a move intention, and we push this move intention onto the entity. Another interesting thing here is because we actually add a component to the entity, we are changing the layout of the entity. So if you recall the beginning, ECS is doing a lot of efficient querying for us. But if we change an entity during an update loop, we create some kind of uncertainty. So all these commands that add or remove a component will be buffered in something called entity command buffer, which is this post-update commands. So it will collect them, and as soon as we're done with the update, it will replay them and change all our entities. So again, this is something where we don't need to care about state keeping during parallel execution, because ECS will do all of this for us. And now we're going to actually switch to the editor. I have my project. It's basically empty, which is not supposed to be empty. That's shitty. I'm going to open an Explorer and copy stuff over. Sorry for this. Well, this is what you get when you do a live demo. So all the scripts that I copied in are the stuff that we just looked in at the presentation. And it's just going to take a bit too much time if I would type it out actually. So what I want to do is I'm going to pull in a prefab that I created beforehand, which is like our game board. And then we're going to pull in some entities. We have the enemy snails. And we have a player. And the last thing that we need to do is we actually need to take our actors and assign the actor component we just created in PowerPoint. And then Unity will tell you that you have added a script that is looking for entity conversion, but you're actually not yet converting it. So we also add the convert to entity script. So by doing this, it means when I press play, all these game objects are going to be converted to entities and then be destroyed in our scene tree. So if I hit play now, we see that all those entities disappear in here, and they are actually kind of creating random movement and are moving in the direction. I mean, it looks like a very cool game already, but it's not yet turn-based. So we're going to take this state and going to talk about how we actually would make this a turn-based game. So the core thing that we need is we need a way to gather player input, or a general way to kind of pass a turn. And the way we're going to do it today is we're just going to assume the player can make a turn, a movement, and whenever the player moves, all the enemies are also allowed to move one step. And then the interesting part is, how do we actually communicate between systems? So how do we synchronize systems in a way that we get the behavior that we want to have? And for this, we're going to look at two different variants. The first thing is going to be manual control. So we're going to do all of the things by ourselves, and we're going to look at pros and cons of this approach. And then we have a second approach. Spoiler alert, it might be a bit better, and which is going to be more ECS-y and use components to do these things. Now, supposedly, stuff is getting copied in the background, which is not. But I'm going to copy some things again. Just quickly open up a second Explorer. So what I'm copying over right now is a player component, which is just an empty component without any logic in it, just for us to kind of differentiate between NPCs and the player character, and an input system that we're just going to quickly look at. So basically, it's also a component system. We are looking for all entities that have this player component we just created. And then we just check the input system if I pressed anything from WASD. And whenever I do, I'm going to create a new move intention, and I'm going to add it to the player. Ignore this line for now. It's going to be relevant later on. So what I want to do now is I go to my player object. I also add the player script. And the last thing to do, because we are generating the move intentions by key presses now, we do no longer want the player to receive move intentions from the random system. So I'm going to go to my random move system. And we have the query up here. And what I want to do is, right now I'm just looking for all entities that have an actor component. And I want to extend it to say, all entities that have an actor component but do not have a player component. So I can have some kind of Boolean operators in this query. So this will exclude the player. And if I hit play now, lo and behold, the NPCs are still moving around, and when I press, I think you have to trust me, I'm pressing buttons right now, the player will move around as well. Still not turn-based. So back to the drawing board. The first thing, manual update. The idea here is pretty simple, especially when you come from the more traditional world. You've been doing something like this implicitly. So why not just take all the turn-based system out of the normal update loop and update them ourselves whenever we need to? Luckily for us, there is some ECS boilerplate code that helps us do so. So there's an attribute that we can put on any system, which is called disable auto creation, and which will yield, which will turn this system into not managed by ECS. So ECS will not automatically create the system for us. It will not update it for us. Instead, we can query for the system ourselves and update it manually. So what I'm gonna do is copy over one empty file. To do this, I'm gonna take the move system and I'm just gonna update this system to have disable auto creation. Same for the random move system, because those two systems are basically what we want to take out of the normal update loop, because the enemies are only allowed to do something whenever the player has done its turn. And then I have our turn-based game loop system, which has an empty update function. And what I want to do here is I'm gonna write a query, and I'm gonna look for entities that have the player component and the move intention. So this means that this query will only ever find anything whenever we press the key and the input system gave a move intention to our player. And what we're going to do in here is we're going to go to world, which is kind of the thing that all the entities in system live in, and we're going to say get or create system, random move system, and update this. So this get or create system gives us a reference to the move system, a random move system, and if there is no random move system right now, it will create one. And we want to do this for the move system itself. So just brief reminder, random move system creates a random direction on each actor component that is not a player, and the move system just takes all these move intentions and changes the target position accordingly. So if we go back to the editor, we should see that nothing is moving. Well, that's good. And if I press a button, you see that when the player moves, the enemy moves as well. I can play it like a real-time game if I press fast enough, but it is kind of turn-based now. So why don't we just stop here? We have very fine control about what's happening, so we can specify the order in which the systems get updated. It has a pretty low footprint because we only need to add this attribute to a system to take it out of the loop. But it doesn't really scale well. So if you think about a situation where you maybe published your game and you want to allow other people to mod gameplay systems, for example, they need to have access to your turn-based game loop because they need to later on include the system in the game loop. Also, if you have like a bit more complex systems that we have right now, so we just say whenever the player has a move intention, you pass a turn. But what happens if we do more actions than just moving around? Like this thing's pretty easily gets complicated because you have a lot of dependencies between the systems, which is something that we would not like to have. So we're going to look at another approach, which is a bit more complex, but also scales way better, as we're going to see in a second, and going to come with some special perks that we're going to look at if we have the time. So the idea is to use components without any data, just like a flag, to communicate between the systems. And the idea here is that every player actor in a scene gets a flag that says, okay, you are awaiting an action. So we have this component on the player, and then when we use our input system, we actually consume this component. So the input system gives the player the intention to move somewhere, and it takes away this flag that the player is waiting for something. And then in our turn-based system, instead of kind of waiting, or instead of calling the systems themselves like we do right now, we hand out like a card to the actors, which say, okay, you're allowed to do something for this one frame. So at some point, the player's going to do something, and then we're going to allow the actors to change the game state for one frame. And if this frame is done, so all the systems have ticked, we're just going to take the card back. And sorry for copying all the stuff, but it was supposed to work better. I'm just going to quickly remove the thing that we had before. Stop play mode. And going to look at a chunk of code. So the first thing that I'm going to do is going to remove the attributes, because if I forget, everything will fail. And we want the systems to be updated by ECS. So instead of taking them out of the normal loop, we're just going to let ECS update the systems, and we're going to put a check into the systems to see if they are allowed to move. Those are the two flags. So we have the await action flag, which will be on the player, saying that the player is still waiting to receive input. And we have the ready to handle flag, which says that an actor is allowed to do something. We will in a second build our turn-based game loop, but before we will prepare our systems. The first thing that we're going to do in the player component, we have this convert function where we take the game object, we destroy the game object, and we add a player component. And additionally, we're going to add an await action flag. So we're going to, when we create the player entity, we're going to put it into the state of waiting for action immediately. And we're going to go to the input system, and here, when we put a move intention onto the player, in the same way, we're going to remove this flag. So as soon as we give the player intention to move, we're going to remove this flag that it's still waiting for something to happen. And I'm just going to add it down here, which means that the input system will only run off players that still await for an action. So if I have multiple players, which is something that will become possible in a few minutes, I will make sure that only the players can receive input that haven't so far in this frame. And now we go to our turn-based systems. And in here in the move system, we can just say that we are no longer running on all entities that have an actor component, but instead we're going to filter and say, okay, you are only allowed to run if you have this ready to handle flag. Same goes for the move system. I'm just gonna add it in here. So these systems will get called on update every frame, but this query will actually make sure that they are only doing something in the update loop when they have this flag. So what we now still need to do is to build a turn-based engine to kind of hand out those things. And we're gonna do a neat trick here. So I'm just gonna create a variable, and we're gonna have a query which looks for all entities that have an await action flag. And instead of using for each to execute a lambda function on it, we just gonna get the entity query object from ECS, and we're gonna calculate how many entities are in there. So basically what we're looking here is for all the entities that are still awaiting action, and then we count how many there are. And then we can do something like, waiting. If this equals 0, so if all the actors that await action have actually received an action, we can go and go to all the actors in our scene. Now we want to change the entities. We're going to execute a lambda, and we're going to say, when you're done with your update, please add a component, which is the ready to handle flag on the entity. So as soon as all the players have received the action, we're going to give this token out to all the other entities. And we furthermore want to reset the players. So we're going to additionally go to all the player component entities and give them an await action flag. And if you think, if you go back to this loop, the one thing that we need to do still is, after we've passed one turn, we need to take this token back, basically, so that the systems are not allowed to continuously execute, but we only want them to execute one frame. So what I'm going to do up here is for every entity that had already a ready-to-handle flag, I'm going to remove it again. So this means basically there will be one full frame where this ready-to-handle flag exists on entity. And now we get the magic code line, because for some reason this won't work. If you include a query which just queries anything without doing anything, it does work. So please don't ask me why. It's something that I figured out late at night, and we're just gonna take it as a best practice for ECS. I assume that it's gonna be kind of disappear at some point. All right, I hope I didn't forget anything. Let me just quickly check my cheat list. Looks good so far. So if we hit play, again, assumption is nothing is moving. Good so far. And if I press the player, the NPC, yes, so sometimes I generate non-valid moves, which would bring me outside of the game field. So if a snail around here doesn't move, it's okay for me. So it works. Nice. And so what do we have what properties do we have here? So it scales nicely, because the turn-based system itself does know nothing about the system that consume this await action flag. It does know nothing about the system that work on this ready-to-handle flag. So it kind of scales for all the system that we're going to introduce later. We are able to kind of front-load some effort. So I could write a base class for systems that should be turn-based, that do all this looking for a certain tech and stuff, and later on I don't need to care about it. Because we are counting how many players are waiting for input, we do have multiplayer, and I'm gonna keep talking a bit faster, so maybe we're gonna hack in some multiplayer here. And on the downside, we have more complexity, so we need to kind of write more code in our systems. We need to be more, we need to think more about how we do our game logic. And if you paid close attention, you saw that the enemies did not move in the first frame. So when I moved the player the first time, the enemies actually did not move, which is because the order of our systems now is relevant. Gonna give a quick look at the entity debugger, which gives us insight into the whole thing that is running on the ECS side. And if you see is that the move system updates before the random move system. So what is happening here is we do our update loop. At some point, we have the turn-based loop, which hands out those token. Then we go update loop. Then the move system triggers, and there is no move intention because it has not yet been created. So only the system after creates the move system, the move intention, and then the next frame everything works like a charm. So there are different ways to work around this. Maybe you're gonna touch some of those. But in generally, it's a downside that you need to kind of think about if you have any order in your system that is relevant for a gameplay logic. So this is like a very bare-bone prototype. You have the turn-based gameplay, you have an idea how to extend it, but we don't have any gameplay. So next step obviously would be to think about what is necessary to win the game, how can the player lose the game, how do all these game thingies come in. Another idea would be to talk about alternative turn modes. So right now we have the system, one player action means turn is passed, players have all done the turn, and enemies are doing the turn. You could also have something like a timed mood, so that the player has a certain amount of time to do actions and then the world turns. Or you can have something like in board games where the player can do as many actions as possible with given resource and then manually ends a turn. You could also go ahead and take all these nice ECS-based packages and put this into the game. So we have the physics system, which is deterministic, stateless, allows us to do all crazy things with multiplayer. We have this live play, live link thing that we can implement in here. So basically, this prototype gives you a good foundation to kind of extend on all the stuff that is Unity working on right now. And I'm gonna skip recap for now. Instead, we're gonna try to turn this whole thing in a local multiplayer game. And I would offer to, like, after the session, be outside for a few minutes, half an hour, to ask all your questions. So if you think about it, we are counting the players. So in theory, if I just add another player and give it the player, actor, and convert to entity script, and hit play now, it is not super interesting because both players will just kind of move simultaneously, because in our input system, we do not differentiate between players. So what we could do in here, and this is not really practiced, so I hope that it will work out, but if I just give the player component a player ID, and I will let's do it like this, we'll also put it into the mono behavior so that I can edit it from the editor, and then I need to change this to not only put in an empty component. Instead, I want to do a new player component, and I want to say that the player ID equals to the thing that I just set in the editor. This. And now I can go to my input system, and I'm just gonna take out the player component in here and put it into here. The change means that instead of just seeing if the component exists, I'm actually going to get a reference to this. This has also some performance implications because Burst is clever, or the job system is clever enough to kind of differentiate between jobs that can run in parallel because they're not reading and writing on the same component, and jobs that need to run back to back because they're going to access the same component. So I'm just going to check if my player ID equals 0. If so, I'm going to do the same thing that I did before. And if not, I'm just going to look for a different set of keys. So I'm going to go for up arrow, left arrow, down arrow, and wait, right arrow, like this. And I just gonna go into the editor, and we can, as soon as we have the scripts, we can take one player that keeps the player ID 0, and the second player gonna have the player ID 1. And if I hit play, I'm gonna press W for the first player. Nothing happens because we still have one player waiting for input. And if I now press an arrow key, you see that both player actually moves. It feels a bit clunky, but in theory you have something like local multiplayer play, which is awesome because we didn't conceptualize our game in the beginning to be multiplayer games. And the way that it's so easily extendable is always something that baffles me. We can quickly fix the problem with the turning of the enemies. Again, there's an attribute, so we can do something like update before, type of move system. So this is just like random stuff that we could quickly use to extend the whole thing. So this means that the ECS update loop is going to take care that the random move system is always called somewhere before a move system. So it will sort it internally, which should kind of get rid of this problem. And the last thing that is kind of nagging me is that I press a key for the first player, but I don't see any immediate response. So this feels very unintuitive. So I'm going to change this for not only look for ready-to-handle flag, but to look for a ready-to-handle flag or a player component. So this means our players have kind of a special role. They will move as soon as they receive a move intention. And if I play it now, I should see that as soon as I press W, the first player moves. As soon as I press something else, the second player moves. And now we have our enemies moving in the first turn as well, but only if both players have moved. All right, so let's quickly recap what we did. So we looked at some ECS building blocks. We looked at how we could connect these, the mono-behavior editor world to ECS. We talked a bit about a turn-based game loop. We talked about how player action could trigger changes in our game world. And then we built different variants of a turn-based game system, which gives you kind of a foundation to kind of extend onto prototype away. That's from my side. Thank you all for staying with me. I know that's a lot of digestion right here. We have 4 minutes left, so I would again say that I pack up my stuff, and if you have any questions, we can meet outside, and I'm happy to answer them. We also have some 3-At Games stickers around, so if you're a sticker person, you don't have to ask a question, you can just grab a few stickers. And thank you for spending your time here.